Hey everyone, so my name is Dinesh. I work at Wells Fargo. I've been an on and off member of this group for last 2.5 years. I did, I think, one presentation about a year and a half ago on machine learning and giving example on how it is being used across movies and stuff, but that was a long time ago. So as a part of 2020, I met again and we discussed the idea of doing things in workshop rather than only demoing. That way we'll have more user participating. So that's why I volunteered. I said I built something, I did something at work I can share with everyone. So that's the background. By the way, which screen, what are you guys seeing on the screen? I don't know which screen is getting shared. So sorry about that again. You should be seeing the screen which has the slides. Is that?
I'm seeing get started.
Lecture 1.
Okay. Hold on. Stop share, share screen again. Let me just figure this. Okay, I'm sharing screen. Screen 3. Okay. All right. So you should be seeing this screen where my mouse is moving, right? Okay. Let me move my presentation over there. So I work at Wells Fargo Bank, and there I built a solution for one of our group using a primitive way of building a chatbot. And then in the course of the project, I came across and worked with multiple chatbot and different solution. I worked with Bing, speech to text, text to speech, then Google, and IBM Watson. And RASA was something which I discovered as a need where we didn't want to upload our data to cloud. So that's why I came across a library called a tool called RASA, and I built this solution using RASA. So this is going to be the first session of this course, and we are going to start right with the bank. I don't know, I'm pretty sure some of you guys have been have learned Fast AI, and I did that course a long time ago, never finished it, but I like the approach that you start with what you want to build rather than going into nitty-gritty. So Jeremy Howard, the person who runs the course, the way he says is that if you want to teach a kid how to play a soccer or football, you don't tell them that there's a goalkeeper, there's a goal post, and give all the rules. You just tell them, here's the ball, kick it, and then once they learn how to kick, then you keep on adding more rules to that and keep explaining the details of the game. So that's the approach we'll be taking. So with that, what we are going to do is we're going to look at what we're going to be learning in session 1 and what is different between session 1 and session 2. So in session 1, right off the bat, you'll be building your first bot. We're going to be learning about what is a chatbot, what is it used for, what is RASA, why we're choosing RASA. We're going to learn about architecture. So this whole thing is broken down into 2 sessions. So basically, when we talk about a chatbot, for a machine to answer you back or converse with you, you need to train the machine to understand what you're talking. If I start all of a sudden switch to Hindi, aapka naam kya hai? None of you are going to understand what to respond with. You'll be like, what did you say? So the first thing that we are going to do is we're going to train the machine to understand what you're talking about. If a machine understands what you're talking about, only then it can respond. If I say, hi Chang, he's obviously going to greet me back. But if I say, aap kaise hain Shriman, which he has no idea what I just said, he won't know what to respond with. So nothing wrong, Chang, I'm just saying hi again in Hindi. So that's the whole point. So session 1, we're going to learn only about training our chatbot to understand the language. Okay. In session 2, you're going to be building how your chatbot should respond back to you when you ask a question to the chatbot. right? So before learning any detail, let's build a chatbot. So people who have already completed the setup can follow along. I'll give you a couple of minutes in between, but I'll be doing everything from the scratch. So the first thing I'm assuming is you guys have already installed and are aware of how to create your uh, environment space in Python, right? So right now I'm in my C drive. I'm going to create a folder called live workshop. So people who are doing, you can go ahead and create your own folder. Make sure you are in your environments right now. My Python environment I've created is workshop, so I'm in that. Everything is installed in there. If you forget to switch, you might start seeing issue that you don't have Python installed, or you don't have a correct version of RASA installed. So make sure whichever uh, environment you have set up your Python and RASA library, first switch to that, activate that if you're using Conda. If you're using pip, use the shell script for activating it. And once you're there, then go ahead and create a folder or wherever you want to do that. So I'm going to switch to my folder live workshop. Okay. And once you're there, the first thing we are going to do is we're going to open up our library, the exercise files. So does everyone know where is the I think I need to mute everyone. Okay. Does everyone have the GitHub link to download the code?
Dinesh, there are people in the chat that says they cannot see what you're doing. We are seeing your file explorer.
Oh, okay. Okay, so in that case, it's this window then. You guys should be able to see my, okay, so none of the slides were there as well, okay. Can you guys see my slides now?
Yes.
Okay, so I've just created a folder called live workshop, and I'm in my Python environment called workshop. And I just created a folder called live workshop where we'll be building the chatbot. Okay. So for people who have just joined or have missed some of the information, all the exercise file that you're going to be following is on this link. Let me put it on chat somewhere. Chang, can you post a link on the chat?
Okay, I will post it.
Okay. So we're going to be following our first exercise. If you have downloaded the GitHub folder, in the GitHub folder, there is session 1, or you can directly go to the URL if you don't want to download. So that's the exercise folder. So in that, there's a session 1, there's an exercise 1. So you go in there, and then at the end, you'll see the MD file. It's a markdown file. It can open up in the in your browser itself, or you can just download and open in any of the text editor. So we did the first thing. We created a folder, we switched to our folder, and now we're going to build our very first chatbot. So the chatbot which we're building, this chatbot is a chatbot which is going to ask you about your day, and if you are unhappy or sad, it'll try to cheer you up. Okay, so the first thing we'll do is we'll do RASA init and hit enter. Something is wrong. Okay. So the first thing it's going to ask is, please enter a path where your project will be created. I want to create in the same directory. So I'm just going to hit enter. And now it says that it has finished creating the project structure. Do you want to train initial model? Yes. So while this is building, you'll see certain logs which will say processing story blocks, tracker, action tracker. So ignore all of those. As we move along, I'll ask you to observe those. What is the difference between the first chatbot, and as you keep adding stuff to that, you'll start seeing differences, and I'll show you shortly. So at this point, what it is doing is it is creating a folder structure, trying to understand some of the basic human interaction utterances. Utterances are nothing but sentences you used in your everyday language. So it is trying to create a simple model on that and figuring out what should I respond with. So one thing you'll see is, this is the interesting pieces. So looking at this, you'll say the number of intent example 43, and I have something called mood, greet, affirm, unhappy, bot challenge, and so on and so forth, right? So these are some of the intents that it is getting trained on. It is trying to see how should I respond with, can I identify a person, name, place, or thing. So if you don't understand any of the word, that's okay. Just keep in mind what are the values showing up, what are the keys defined in here. Okay. So at this point, it says that it should say that your model is complete. Do you want to speak to an agent? So let's say yes and see how does it behave. Okay, so I'm going to respond with hi. Let's see what. So it'll simply say, hey, how are you? Okay. Let's say I'm good, and the bot says great, carry on. Unfortunately, I can't change the text on this. I think these are set by default, but if you're doing it on your machine, it's coming in blue, so I don't know if you're able to see that. Okay, so let's say bye now, and let's try one more in there. We're going to say hi, and this time we're going to say I'm not very happy. Okay. So it's a stupid bot. All it is trying to do is just telling us, here's something to cheer you on. It's sending me a link that I can open. Let's open the link. And it should give me, okay, so it should give me a little cup picture, tiger cup, to make me happy. That makes my day. So let's say yes, it did help me, and it's going to say great, carry on. So let's stop this. So to stop, you can just give a / stop. It's defined over here, and that completes your first chatbot. You just built a whole chatbot, right? So this is as simple as that, a basic chatbot which took literally like 5 minutes, but that's not what we are here for. So we're going to build something more complex. Okay, so let's learn about what are different kind of chatbots and what exactly is a chatbot. So chatbot is nothing, it's just a conversation assistant that helps you save time and gives you somebody to talk to. If you want, you can ask questions like you've been asking Siri, do you have a boyfriend? And it says, why do you care? So you can build things to pass your time. You can build things to automate some of the stuff. You can build things where you don't have to walk. You can build things where I don't even have to lift my remote up and say change the channels. So chatbots can come in different shape and sizes. It can be a text chatbot. It can be a chatbot where it notify you of something. A chatbot can be a conversational chatbot, a voice activated chatbot where it's going to respond back. So all of these, actually, the text chatbot, the voice chatbot, they all work the similar way. Actually, they have the same key markings in there. That is, whenever somebody talks or writes down their thoughts in words and puts it out there, they break it down, they try to understand, and then they make a decision, how should I reply back with, right? So you have been seeing chatbots and different form of assistants so far in your daily life. We have Google Home, Alexa, You have chatbots on Facebook where it can come and help. The very first chatbot that I remember, a very vague one was, I don't know, probably showing my age, but I'm talking about Windows 95, where when you open the Word document, it would show a small irritating clippy, which was always eager to help you out, say, and asking you, do you need help? Do you need help? And you type something, it used to tell you, okay, if you want to bold text, you do so and so stuff, or it'll simply paste a URL to you. So that was my very first chatbot. I didn't know it's a chatbot, but it was called Clippy, and that's what I used to call. So uh, going back to like 15-20 years, the very first chatbot, which some of you may not realize, is the are called level 1 chatbot notification. When Amazon and eBay, when they first started collecting your information on phone number, whenever you bought something, they would push notification to you, right? For example, if I bought something on Amazon today, it's very common. We don't even bother, but you can turn on a notification, you get that. One very good example, it's heavily used, is USPS website, where if you have a tracking number, you just put in a number and it sends you text on your phone telling you what is the status of the package you're tracking. There is no way you can communicate back. It is just an information. It just pushes out information based on a certain event, right? So those are the level 1 chatbot. Level 2 chatbots are kind of FAQ assistant, as we know. So they don't tell you much. They don't go back and forth. All they do is they provide you information on what you have asked. So for example, then this is the chatbot which I started with, a very crude one. So if you look here, the example that I have here is customer asks, I need to renew my renter insurance. How much will it be? The chatbot simply gives you the link, because it cannot, to answer your question, it would need to know more information about you. Where do you live? What is the zip code? What is the address? What is the size of the house and all those, right? So rather than figuring that out themselves, the level 2 chatbots are not very active. All they do is, and for building this kind of chatbot, you don't need any special library. You can do it in any language, JavaScript, without any knowledge of machine learning or anything. So what you do is, and what I did in my first project was, I simply said that if my input sentence is in English and I see a word called insurance, I'm supposed to respond back with this canned response. I don't need to know anything. So if somebody asks how much is it to renew my car insurance, how much is it going to cost to renew my home insurance, I didn't care. I would simply send you a canned response to calculate your renewal price, go to the website. Those are canned responses, right? And these are built on a simple set of rules. Like explained, I created hooks where I'm simply tracking the word. If in the sentence I see these two words together, I'm going to respond back with that. Eventually, the problem with this type of approach is it's good to start with, but as your chatbot gets complex, right, depending on domain, right, as a chatbot gets complex, your rule set is going to become very murky, actually. So to give you an example, if I would have asked how much does a baby monitor cost, the chatbot I've specified that baby monitor is supposed to cost $25, right? Now imagine if I just switch two words in there, how much would a nanny cost to monitor a baby? That it would come back and say, I see the word baby and monitor, I don't care what is the sequence, but it'll say it is still $25. I would immediately hire a nanny, because today's date, I know it. My friend had a baby and they had a nanny, and she's charging him an arm and like $2,500 the last time I heard, not including the privacy issue where they stay in your house. But that's a way that these chatbots can trick you, and then you run into challenge of providing wrong information to your client. So the next one, the next level of chatbot is contextual assistant, which is what we're going to build today. it's a full-blown back and forth where the chatbot can understand what you're talking about. It'll understand what is the context. It'll be able to hold conversation with you. It'll be able to hold chit chats with you. When you call a center today, right? The call center guys usually ask you a rhetorical question, how was your day? And some people like me would go into big length, oh, my babies are, troubling me today, I have so much work, they don't care. And they'll be saying, and eventually they bring you back. If I go on for 45, they'll bring you back. By the way, why did you call me today? To get me back on track, right? So these chatbot can handle some level of chit chat where people can go off track on what they're supposed to be talking about. So these can bring them back. They can hold a history of conversations. For example, if I say, give me can you help me how to cook spaghetti, right? And it says, sure, I can tell you, let me find that for you. And then you ask a follow-up question, do you think it'll taste good? Now, when I say, do you think it'll taste good, the chatbot doesn't know, a stupid chatbot won't know that what is it over there. But a contextual assistant would know that you're talking about how to cook a spaghetti. So this question is a follow-up question of spaghetti, and it should respond to you back. I think it'll taste good, it'll turn out to be good if you cook well or you follow the instruction correctly. So these are the kind of chatbot which are coming in level 3. And as of today, the 4th level of chatbot called personal assistant, they are supposed to be futuristic, but they're already here actually. Some of the companies are actually using that. So these are personalized assistant. If you have noticed, couple of years ago, I mean, these chatbots are actually here. Couple of years ago, when I was first looking to learn into machine learning, I was looking at courses, searching on Google, and I didn't realize, but after a day or two, when I went on YouTube to watch a totally irrelevant topic, kittens crying or kittens playing or whatever, it started showing me ads that here is a course from UIUC, here is a course from SFO where you can learn about machine learning, because it was tracking my needs that I have been searching for how to learn about machine learning, how to learn about deep learning. It was keeping a track and was giving me a personalized service. I was seeing ads in my Gmail account about these. So these are the type of chatbot that can remember your preferences and give you advice on many of the things. There are many investment personalized solution available today, like Wealthfront, Betterment. They do something similar where you just specify your needs, and they would be sending you notification on, do you want to buy this stock? Because we feel it has so and so potential. So they can provide advice on those, pre-built advice to help you do all that. So these are all already here. Amazon Alexa, you would start seeing what you search, you would start seeing it is showing up on your Amazon account as things you might be interested in. And the 5th level is the autonomous organization. This can take over a wide portfolio. So Google is a very good example, but in this one, you can relate to Google. So if there is a company called Acme Insurance and you are an employee and you pick up a phone to ask a query, right? So these claims, admin, HR, finance, they are all individual isolated chatbots, but the centralized chatbot, it depending on what you have asked, it is going to connect you automatically to that individual chatbot and is going to give you a response back. You may jump from one item to other. For example, if I say I have to file a claim on my office desk to get some money back because it broke, you are able to file a claim. You say that I'm going to file a claim for $200, and then your next follow-up question is, because I filed a claim, my desk is broken, I need to buy a new one. So it'll automatically get information from the sales bot and is going to get you that you are only authorized to buy a desk for up to 500. So these kind of chatbot take over your whole organization, your whole life, where they can hold a real life conversation. So one of the good example is I believe beginning of this year or last quarter, Google had released a video where Chatbot was actually making a human-like interaction with the restaurant where it was trying to book a table for two, and it was the person at the other end was not even able to tell whether it was actually human or a chatbot. And when the restaurant said that, sorry, we don't have a table available, would 8 p.m. work for you if 7 p.m. is busy? The chatbot was able to say, sure, let me check my schedule, and she checked the calendar and came back, yeah, sure, book it at 8 p.m. So those are the kind of thing where you'll have a the autonomous chatbots are going to come into picture. So we are almost there. Probably in a year or two, you'll start seeing that, right? So coming to RASA, what is RASA and what can you do with that? So it's a set of open source machine learning tool. It's a library that you can use for conversational API. It has two main parts. One is the NLU, one is core. NLU stands for natural language understanding. Basically, what natural language understanding means, a person can ask a same question or have a same query in multiple languages, right? So I can ask a sentence, what is your name, in English. I can ask the same sentence in German, French, or whatever language. My chatbot should be able to figure that out. My chatbot should be able to tell that when I ask a question, does my question has a specific keyword that I need to understand? For example, if I ask a question to Google today, how high is Mount Everest? The Google, the way it'll be thinking is it'll be dropping the words like how, giving it a lower priority, and say that, okay, there is something being asked about something called Mount Everest, and now I need to relate it back to the first word called how. And how means it is related to a question about Mount Everest. What is the question? High. And that is how it gives the priority. So Mount Everest is going to be priority 1, how is going to be priority 2, and high is going to be 3. And how and high are going to be connected together, because you need to have a connection between a question and the context. It can also be how heavy is a Mount Everest. In those cases, the answer is going to change. So those are some of the things the NLU library does, and it is one of the key thing in any library you pick up, whether it is RASA, whether it is Google, IBM Watson, or you pick up Spacey, MITI, so many other libraries are there. This is one of the key things that they do first. They try to understand what you're talking about. They try to figure out what is your intent on that. Why do you want it, and what do you want to do with that information? The second part is the core, which we're going to cover in the session 2, right? So in the core, what it does is, after it understands what you're talking about, it figures out the dialogue management. It makes a decision on, okay, you have asked me a question, how should I respond to you with? If I say, hi, my name is Dinesh, should I respond back to you with just a hi, or should I say, I'm good, how are you? Or if you just say hi, it needs to think, okay, I see a hi, the person is greeting me, should I just respond back hi, or other than that, should I also ask what is your name, right? So those are some of the things that that is done in the core. After understanding, it needs to make a decision. So that portion takes place in the core. Okay, so I've been talking about entities and intent. So to give you an example, in the NLU, when somebody says, hello, my name is Dinesh. So Dinesh is an entity, and this entity in the context of the whole sentence, right? The intention is to greet. I'm greeting somebody, right? So for people who are from arts background or literature or grammar phonetic, you can think of entity as a noun, name, place, animal thing. It was also a game, I don't know if you guys played as a kid, where all the kids would get together and they have nothing else to do, no toys. We used to play, I'm going to say a letter, and everybody is supposed to write name, place, animal, and thing with that letter. So for example, if I say A, so I have to think of a name with A for Andy. Place could be Andaman, and then name, place, animal for ant, anything, insect or anything, and the thing could be antelope or whatever, right? So these are, that's exactly what entity mean here. Anything which you can identify, any person or thing is called an entity. And the entity in the context of whole sentence tells you what is the intent. The second part, core, is where when I say hi, the bot is supposed to be thinking that, okay, he's greeting me. Should I just greet the user back, or should I tell my name and ask his or her name back? So this is what is happening in the core actually, where it is trying to make the next best action after you have asked a question or just a statement, right? So that's what happens in core, and we'll see that in session 2. Next, we're going to work on learn about the architecture, and we're going to be building our first full-blown chatbot. So what we'll be building, since it's COVID-19, no surprises, we'll be building a healthcare chatbot. And the whole goal of this chatbot is that it is going to be asking you about, customer may ask something like, can you tell me a nearby hospital? They may or may not provide a location. In that case, chatbot is supposed to ask you back a question that you're looking for a hospital, but in what location? So city or state is something which they have to provide, and then chatbot is going to give you the answer back. In case I say, hi, I'm looking for a hospital in Charlotte, it is simply going to say, let me look it up for you, and it is going to give you an address back. So with that, you can take out your notebooks and start the second exercise. So I'm going to be opening my exercise 2. And I'll click on exercise 2.md. So I'm using Visual Code. If you have any other editor, you can use it. Since it's an MD file, and you get bugged on by looking at all this hyphens and stuff. You don't like that, you can just switch to the preview mode and then look at it over here, or you can get the same display if you open in your browser as well, right? So what we're going to do is we're first going to look at NLU.stories and stories.md files. So let's open those files. They are under your exercise 2 data, and you're going to look at NLU.md. Actually, I'm opening a different folder. Let me open the one which I've just created. Live workshop. In my data folder, we're going to look at this one. So these are the file. By the way, these are the file which got created when you build RASA in it. These are all the folders and file that are created for you. So we're going to look at all of these files, what goes in there as we progress. So for now, we are only going to be focusing on 2 files. One is called an NLU, other is called the story. So NLU is your natural language understanding. So if you open that file, what you will see is that it has all these words like hey, hello, hi, greeting. So these are called utterances. Okay. So by utterances means what are the different ways a user can ask you a question? What are the different ways somebody can greet you? So if I have to ask another way, or if I have another combination of sentence where I want to teach my chatbot to greet, I can go ahead and simply add. And let's say if I add how's that? Okay, just say howdy. All right. I just train the NLU, and I can just go and see what is it going to do. So to train your chatbot, you say RASA train NLU. Okay, so it's going to run the training, and then we'll see if it is going to reply me back if I type howdy there. So while it is training, let me show you what else is there. So we have intents called goodbye, some of the utterances. Affirm, when you say that, yes, I'm happy, of course I'm happy, of course I'm unhappy. These are some of the utterances. And we are simply saying that if you see any of these, the intention of the customer is that they're affirming something. And these name can be anything. You can call them, these are custom defined name. Instead of goodbye, I can simply say intent is sayonara or whatever. You'll understand. All we're giving is a name to the intent. And then we have some other ones, bot challenge, where we can ask them stupid question: are you a bot? Are you human? And those stuff. And it is supposed to reply back with the answer. So okay, so it has trained, and now we can we should be able to test it out. The model completed. Okay, so after you have trained, you can now see how it's going to respond. So I'm going to say RASA shell. So RASA shell is just your way of testing your chatbot. Okay, so let's say I type hi, and it comes back that intent is equal to greet. Right, so now I'll explain what we're seeing here. Now let me try if it identify. I just added something called howdy, and yes, you'll see. So what you're seeing right now is the ranking of all the intents you've defined. We have multiple intents here, right? If you look at the one intent is called mood great, one intent is called mood happy. The intent that closely matched was greet. You'll see that it is also talking about other intent. What is the confidence level that it was able to identify? So with greet, the confidence level is 99.99%. There are others as well. So affirm is 3.9, unhappy is 1.01%, bot challenge, and so on and so forth. So it's going to give you all, but when you're talking, right, you can actually define when you're actually building a full-blown, say you're providing this as a service, as an API, where somebody want to get multiple intent, and you'll come across this when you build a bot, something like a sarcastic chatbot, where it can have, where one word or one sentence can have multiple meanings, right? So in that case, you may want to say that, give me choose a response which is at least above 50% confidence. So that's what this confidence number help you with. Okay, so let's get back to the exercise. So the next one, what we're going to do is, now we're going to create a chatbot. So before we build, I missed one portion, I think. Before we build, I want to understand the design process. Like, okay, I know what I want to build, but how do I build it? Before you build, you need to put down your thoughts. You need to understand who is going to be using my chatbot, what do they need, and why will they need it, and what is the most difficult question. So if you look at the first two, they are fine. The third one is a little tricky one. Why will they use an assistant? So I'll give you example of something really stupid that we did for one of our projects. So we were supposed to be so I am responsible for building APIs in my company, just like your Facebook API, right? Where you link your accounts, say that I want to log into your website using Facebook, right? So I built those sort of stuff. So one of the API that we built was move money from my account to your account. The Zelle or Venmo, if you have used, it's exactly same. So we build that, and then I present one of the idea that why don't we build it as a voice assistant as well. So I built it over using Alexa skills, and I simply connected that. See, I can transfer money from one account to other. Security team came back and said, but how are you, if I have Alexa in my home and my kid simply says, transfer my money to Chang's account, and it's not going to verify where's the security. So I said, okay, fine, I'll ask chatbot to first provide your password. So one day I am using, so my kid doesn't understand. I use a very complex password, 24-digit keyword or something. And then one day invite Chang to my house, and Chang has a very sharp memory. Whatever he hears, he retains. He is in different room. I say, Chang, I'm transferring $20 to your account, and then I go and get some water. And meanwhile, Chang says, hey, transfer $100,000. I wish I had that to my account. And then while I come back, Chang is gone, and I'm looking for him all over the place. So that is another security concern, that, okay, I can't ask for passwords now as well, because somebody can record it and then repeat the password. So that's another security question. I'm like, okay, then let me ask Chatbot to send you a one-time password to your phone. We build that. So now when I say transfer $20 to Chang's account, the bot says, I just sent you a one-time passcode. Please say it out loud. And I'm like, that's good. If I have to pick up my phone, why would I want to use an assistant? I could have simply done it over phone by that time. So that is a very wrong use case. So you need to think, why will they use an assistant? You need to make sure that so the whole purpose of building a chatbot is you are lazy enough to pick up a phone and converse with a person, or you're lazy enough to go all the way to the bank to take out some money. So you have to assume that your customer is really lazy. They don't have anything else to do, and this is the only way they want to interact. So you need to figure that out. Why will they use an assistant, right? And the most difficult question that you'll ask the bot in Siri's case, we asked that, do you have a boyfriend? Will you marry me? Which was a tough question, but Siri always dodges that question today. So you need to ask that. So in our case, the most difficult question in healthcare that I can think of is, if somebody asks that, find me a hospital which has a advanced level skin cancer unit in there, or has a special child care unit in there. Those I would consider some of the difficult questions, because bot may or may not know, right? So those are the things which you need to figure out before you even build a chatbot, right? So next is, okay, I figured all those things out. Where do we get the data from? So we saw that the simple ones which you saw here, like greeting ones, right? If I have to greet somebody, I can go and put in some word, hey, hello, hi, easy enough. But if I have a need for something like a hospital, or say if I'm building something related to um, um, something for a doctor's office, where they keep talking about cryptic word called LDL, HDL, which are related to cholesterol, which is very high in my case for some reason. And the chatbot needs to understand those. But if I'm not from that domain, how am I going to come up with those words? How am I going to come up with, these are the acronym they typically use. For example, LDL, I think it's low diabetic something full word. So, but I don't know that in doctor's office, do they call LDL, or do they spell out the full acronym? So those are something where a domain expert is going to help you. Somebody who is a doctor, you can ask that, how do you guys regularly interact? Or you can just put a recorder in there and listen to what they've been saying. That's one way. Hire a domain expert. Other ways, you can use many of these search engine. Google used to have something called Google Keywords, where you put in a word and then you can see what are the possible queries that people search, right? So if I just put machine learning, I can find that some people search using sentence like, how do I learn machine learning? Show me all the course. Show me the best courses in machine learning. Show me the best books on machine learning. So I can get a list of query and I can start with those to start, right? The third one is what I built at my office was using chat history record call logs. So for companies who are not in the machine learning domain, and they don't have any chatbots, people usually call, and 99% of the time those calls are logged. So you can either listen to the call records, or you can use, there are several tools out there. I think the oldest one I'm aware of is called Dragon tool, which can convert your voice to text, and then you can go over the text and filter the things out, and then you can figure out what are the different questions. That's one way. And the third is called Wizard of All technique. If you don't know anything, you be the customer, you be the chatbot. Hi, I go on the other side, I say, hello, my name is Dinesh. What do you want? And I again answer back, pretending to be a chatbot. That's called wizard of all technique, one-to-one conversation. You can come up with at least some questions that customer might ask and some possible answers to that. Okay, so in our case, let's go over the question. Who will be my user? It will usually be patients, users who are new to area, or I went for a vacation and I have a medical emergency, I want to find it out, or a family member of the patient. What are their needs? They'll be looking for nursing home, hospital, dentist, doctors, nurses, some specialist or some sort, right? Why will they be using? They can use it for themselves. Their family member can call if it's a medical emergency. Say you are out on the road and somebody falls sick. You want to know what is the closest one. The most difficult question, like I gave you the example, hospital with cancer specialty or special child unit and so on and so forth. And one example is they can ask like, find me a hospital in 28027 zip code, right? So I know some basics on we have thought on that. So now we have to come up with the design flow. So the one flow is when customer just says hi, the bot will simply say, how can I help you? Customer provides the full query that find me a hospital in Charlotte, and it is going to come back with the address. If customer doesn't provide you with the address, it simply says find me a hospital. In that case, bot is going to ask you a follow-up question. Give me your city or zip code, and I give us the city name, and it says sure, I found the address for you, and then it is supposed to say goodbye and get lost. So with that, let's get to our next exercise. We'll continue on the exercise 2. We're going to make our chatbot understand what we just talked about, right? So if you open up your file, the exercise file, we were somewhere over here. We did the first thing. We understood about what is the NLP, what is the stories. Stories is something we won't be covering in session 1, but let me give you a quick overview. What does story have? So story is nothing but your flow, which I just showed you on the screen. So we saw that our bot should do something like this. If customer says hi, if I'm a bot, I'm supposed to reply back with a greeting. Customer asks me a query. If I have the full context, I'm going to provide a response. If customer doesn't provide me full, I'm supposed to reply back, ask back a follow-up question, and then give him back the correct answer. So stories is exactly that. It is a flow of how a conversation can go, right? If the wizard of all approach I explained, right? I'm a bot and I'm a customer, and I keep asking, hello, my name is Dinesh, what's your name? So I can go back and forth. So this is exactly that. The first time when customer comes in, he's going to greet, then the bot should reply back with a greeting. If he says my mood is great, it should come back with the great carry-on message. If he's sad, then it is supposed to tell me something about cheering me up and then ask me if that helps. So these are some of the sample flows, right? So now that's what a story contains, but this comes under dialogue management session 2. So we're going to skip this and follow on the exercise 2. So in exercise 2, go ahead and delete everything other than your, let me just switch again. It's very difficult for me to delete. So go ahead and delete all the intent other than greet and goodbye. So this is my NLP file. It's under,
So I want to delete like the city names and stuff.
Mm-hmm. Yes. Yep. Okay, so I have the file. So other than greet and goodbye, I'm going to delete everything else. Okay, so now I'm going to, I'll leave this bot challenge. I like the kind of question people ask. So what I'm going to do now is I'm going to add these cities in there. And I'm going to call them that these are information that customer is providing. So I'm giving them just these values, and we'll see that you don't have to give all the city name, and you'll see why shortly. So now I added the intent that customer can come back with a city name, and here are some of the sample cities, right? And then the next type of information that customer can ask is about finding a facility, right? So I'm going to copy this intent called search provider, and here are some of the samples. Customer can ask, I need a hospital, find me a nearby hospital, show me healthcare agency, I need home health agency. So these are just sample. You can add more if you want. Let's add one more. Get me to a doctor, for example. Say you've been listening to some of the call, and people can ask these sort of questions. Caps, no caps, small caps, does not matter. You can put in however. All of these, when these are model is created, everything is converted to small caps. So it doesn't matter whether you give a capital G or make everything capital. It won't matter, right? So at this point, I have added two intent that customer can provide this information, city, or it can ask one of the queries, right? So having said that, now let's go and train and see if it is able to find our intents. So command is the same. Let me just get out of this first. So let's train it again. RASA train NLU. So now what we see that different, the log which I was talking about, now you will see that all the intent which you were defined earlier, right? Affirm, and those are gone. And it has identified that we have defined an intent called search provider, and we have added a new intent called inform. So you can see the two intents have been defined. It was able to figure it out. It doesn't have any responses entities yet. So that is the clue for the next one. So my training has completed, and okay, so let's see how did it, is it responding correctly? So RASA shell NLU. Okay, so let's straight away start asking question, right? So let's say I want to ask, anyone want to volunteer with a question? Okay, silent crowd, never mind. Let's say,
Can I volunteer?
Sure, why not? What should I ask? What do you want to ask?
Show me that you're prove to me that you're not a bot.
Okay, sure. Prove to me that you are not a bot. Let's see what intents can it found. So it found that you're asking a bot challenge question with a 99% accuracy, that you're asking something about its identity, and which we have defined in our, which is defined here, right? And you'll see that there is no such utterances, but it was able to figure out that the intent is you're challenging the bot about its identity. So it was able to add that. Okay, let's try now one of the question about hospital. So I don't have any question. Let's ask a direct question first, and then we'll see how does it behave when we ask an like utterances which it hasn't recognized. So I'm asking exact when I say I need a hospital, and it says that yes, I understand your intent is for searching something with a 99 accuracy, right? Now let's try to find something with it has hospital. Let's find a dentist. Haven't specified any dentist. Let's see if it can find a dentist. Find me a dentist. Okay, and it is able to accurately tell that you're trying to find something 99%, right? Let's say I now want to search about a city. Let's say Charlotte, and I'm able to see that this is an inform type. Intent is you're informing me about a city. Let's take example of a city which it doesn't understand, and I'm providing state as well, right? So let's say let's take a city first called let's take San Mateo, and it is again able to identify that, but with the accuracy has gone down. You'll see it's 95% and it is still informed. Let's put in something like St. Louis, Missouri. It is still okay. So now you will see that it was not able to identify correctly. And but if I provide, let's try if I give it the full name. Hopefully spelling is wrong. No. And sure, it is now able to identify that it is something related, but again the accuracy is still not 99%. So so far it is working fine, but you'll see section over here, right? Entities empty. It hasn't identified that in what context are you asking me that question or providing me that information. So that is where we're going to continue on the next part of the exercise. So the above only classifies your intent of the customer, right? So we need to understand how to figure out how to train the bot to understand this is a name, place, animal thing that it is supposed to extract, right? So we saw this. What does a confidence level mean? What are these ranking? And the next one is what we're going to cover in the third exercise. So let's move on. But there's one piece I want to run by the time we get to third exercise. I want you guys to open exercise 4, I believe. And in exercise 4, while I go over a little bit of theory, run these command in your workspace, pip install spacey, and these command one after the time. By the time you get to third exercise, you will be able to, these libraries will be installed. And if you're using Conda, you can use these command. Just run these so it can install this spacey library, and we'll download a Word embedding for you, and then we'll cover what those are when we get to the next part. Okay. Anyone wants a break or want to catch up on the exercise? We can stop for 2 minutes, or if you want, I can continue. Anyone? Okay.
Anyone have questions for Dinesh?
Yeah, please go ahead. Where do we find question? Is somebody putting in the chat, or you can just unmute and go on? Let's see if I have anything in the chat. Okay, the chat screen is gone again. I can't figure out how to get to chat. So if somebody has posted in the chat, sorry, I can't find the chat window if you have posted a question. If not, then you can just ask over the video.
I'm not seeing a question in the chat either.
Okay. You guys are silent crowd. Never mind. I guess either I'm doing too good of a job, or people are not following. It could be one of the two. So
Hey Dinesh, quick question. Can you hear me?
Yes.
Hey Dinesh, this is Naji. Thanks for the presentation. So I just wanted to understand how exactly this training occurs.
Mm-hmm.
So is the training is done by giving thousands and thousands of interns or questions?
Good question, and that is what we're going to talk next. Actually, that's the next topic on how you're going to design those. How much data do you need? So we're going to cover those in exercise 3 and 4.
Okay, thanks.
So is this project already live for Wells Fargo? It's like something you built in the past, or like what's the context there?
So I didn't build this exact one. I built it for chatbot for auto loan, where if you try to talk through the website, it is going to open a chatbot for you, and you can ask a question that I have a 1980. I'm trying to buy a 1984 truck, and it has like 180,000 miles on it. How much do you think the insurance would be? And it is going to come up with it is going to ask some follow-up question: where do you live, your age, and all those stuff, and then it's going to give you back an answer on that. And I don't know if the team which I helped with, they built the chatbot piece, but the grand plan was they also wanted to make it live over a phone. So if you call, it is going to behave the same way. So that it will still be calling the chatbot, but I had suggested that they use IBM Watson or Google text to speech, and it is going to just reply back. But I don't know if that is implemented yet. But the text piece is done. The text responses are already built in.
Cool, thanks.
Okay. Anything else before we move on? Okay, how are you doing on time? 8 or 9? Okay, we're good. So let's see. So far we helped. We built the chatbot to understand our intents, what we are talking about, by providing some utterances. Next, we need to understand how to train a chatbot to understand what is an entity and what kind of entity. So when I say entity, right? Entity is name, place, animal, thing. You can go home and play with the kids if you have, but you need to then classify them. Like if I say elephant, what kind of entity? It is an entity, but what kind of entity? And that is something called as, in chatbot, what we call as labels. Elephant is an entity of type animal. Mount Everest is an entity of type thing. A chair is an entity of type thing. So when you are defining the entity, what you do is you put the entity in square bracket and a label. Label can be anything. You can provide location. You can call it city. It is a label which you define, which you understand. So that's how we're going to do. So for the inform, I'm going to be specifying that Charlotte is an entity, and the label I'm giving it is location. You can call it city if you want, or you can call it hometown, whatever you want to call, but they're all going to be the same. That these are all the cities, they're all of type, label type, location. Same happens in there. If a city is present in a sentence, find me a nearby hospital in Charlotte location, I'm going to mark this, that in this context, the entity is coming towards the end of the sentence. I'm just going to mark that Charlotte is an entity of type location. Okay. So with that, let's continue with our third exercise. In that, we're going to be adding the entity. So let's go ahead and open the third exercise. Oops. And in the third exercise, we are again going to be working with our nle.md file, and we're going to append the entity in inform, and we're going to add in the search type as well, right? So let's copy this thing, or if you want to do it by hand, you're free to do that. So I'm now going to just find my inform, and I'm going to define it as an entity. And these are all markdown file. They are very simple to work with. If you haven't used and you've been writing pages, HTML pages, providing header and all, it's very easy to do in markdown. This double hash means it's a header type 2, and this is actually a link. If I had to provide it as google.com, and I click over it, it'll try to open as a link. But in the context of RASA, it is we are defining as an entity. So I've defined Charlotte as location, so it understands that these are all entities of type location. And I see that in the context of search provider, there is one more word, Charlotte, which is I have to tell that this is another one, which is an entity, and it is of type location. Okay, so that's all I have. Any other entities you guys think is available in this? That's a pop quiz for people over here. So
like maybe like doctor.
yeah, good one. So doctor, I can define as an entity, and I can provide something called search facility, because I'm not looking for a doctor specific, I'm looking for offices. So somebody can simply say a doctor, but he means I need to get to a doctor's office. So I'm going to provide this same one, and Chang gets 10 on 10 on this. So I'm going to
Xing Xing also says in the chat says hospital is entity.
Yes, that is also an entity, and we're going to mark it now. So I'm going to call these entity as a search facility. So let's quickly copy paste some of the things. Hospital, health agency is also hospital. And I'll tell you one more thing when we get there. What happens when I create an entity, mark something as an entity which is consisting of multiple, like health agency is two-word entity, right? And we'll see what does that mean. So let's add this. Okay. So what actually happens is when I define this entity, I'm basically training my chatbot on creating a model. Basically what I'm telling it is that I'm basically teaching him grammar of a language. So for example, if I'm not really good with explaining grammar, but think of it like this. If in certain language, I'm specifying that my grammatical structure of a sentence would be that a noun comes after before a verb. This is one of the sample. If adverb comes before a verb, this is a sample of a sentence. So that's exactly what it means for a chatbot when you define entities and their placement. So for example, the earlier example we talked about, right? What is the price of a baby monitor versus how much would it cost to hire a nanny to monitor my baby? So baby monitor and monitor my baby are at different locations, right? Monitor in first sentence, monitor comes after the baby. In the second, monitor comes before the baby. So those two are two different contexts in two different conversations. So we are just teaching a chatbot that if you see this sort of sentences where a verb come after noun or noun come before verb, what is the intent? In those cases, your intent might change, or you may have a multiple intent in that case. For example, if I in the term of when I say something like a word called balance, in general conversation, it could be your a balance which you use to weigh thing. But in context of banking domain, a balance could be your cash balance, your account balance, or your 401k balance, which is going down the drain at this time. But moving on, so that's what we are teaching how to create a grammar and understand the structure of a sentence. Okay, so we have trained this, and I think the next one is to just start train the model again. Before I start the train, let's take a look at the what we had earlier when we first trained, right? Let me go back to the log again. So if you would see here, right now we have it has found intent, but it hasn't found any entity examples, and that is reflected here as well. There are no entities it has identified, right? So let's go ahead and see whether it is able to identify the entities now or not. I need to exit this. Train. While it is training, let me show you when it creates a model, where do those model file goes. So if you go back to your folder where it created your all these things, right? So over here, every time I'm going to create a model, it is going to put the model in a big file and it's going to keep updating. And whenever you say RASA shell NLU, it is going to pick up the last model which was trained. And the reason it keeps adding these files is, imagine you're working on a live project and you built your first chatbot, which is working absolutely fine. And now you're tinkering with it. Let me see if I change this setting, how is my model going to perform? And if you didn't had an old model file, you just crash your whole chatbot because you introduce a bug and you don't know how to go back to the old model which was trained. And that is why it keeps these files. So I can simply specify that which file I need to call in. I can roll back my changes by going back to the old model. So right now, if you see, it has added one more file over here, which is at 8:18, and I think I'm running a little behind. So let's continue. So now when I say RASA shell NLU, now you will start seeing that the entity will be displayed, how many entities it has found. And over here, you'll see that it has found 2 entities. One is called search facility and one is called location. And now if I say, show me a nearby hospital. Okay. Now you will see that it has found a search provider, and now entity says the entity type is search facility and the value is hospital. And the start of this is at position 16. And the sentence, if you go over it, if the hospital starts at 16 and ends at 24, and it is able to identify that, right? So if I say, again, if I say, let's say San Mateo, California, it will be able, it is saying that, okay, it has found something called San because we have an example for San Francisco, right? And that is what I was talking about, the importance of having an entity which has 2 words in it. So one of the example is here. We're going to play around with this health agency. So the way it is able to figure out that which is the entity, because it says that I am able to find out an entity, although you didn't give me a full word, but I have a partial one and here is a partial match for that entity, and that is how I'm able to locate. So now let's see if I say, find me agency. And now you'll see that it is saying that I found the word agency because you have an entity defined as health agencies. And you see that it is IES. I'm asking a singular agency. So it is able to understand that agency and agencies are basically same thing. One is a singular, one is a plural. So it is able to identify that. There is one more called home health agency. Let's see if I do doctor. I don't have any office, right? Let's see what happens if I provide something which it doesn't know today. Okay, find me an office. And in this case, it was not able to find any of that because there is no word called office. But if I say, find me a doctor's office, you'll see that it is able to identify the word doctor and a search facility because we have that. So that is how we train to identify entities and then link it back to the intent. Okay. So I think that's all there is in exercise 3. Anything else? Okay, I think that's all we had in exercise 3. So moving on. Okay, let's one exercise. If somebody is following, I'll give you 5 minutes to see. Try adding a zip code as a new entity and label it and see if you can see the zip code identified. And after couple of minutes, you don't have to add like 100 of zip code, just provide 2 or 3 and see if you're able to get it working.
I have a quick question. So like, yeah, it looks like if an entity wasn't specified in the data, and it will not get picked up. Let's say if I don't know if I put in like Seattle or something, like what is Seattle? I don't think at least.
Okay, let's try Seattle. I'm going to go a step ahead and provide Seattle, Washington. Let's see what has come with. So it is able to find out that it is of type location and Washington. And we'll cover how it's able to figure out. Let me show you something else now. Let's put in something called office. This is office building, totally unrelated. And now you'll see that it won't be able to get anything. But if I just put the word building, it was not able to do about build. Okay, so it's not able to find it, but some of the words it'll try to put it in there. So playground, it won't be able to do that. So reason it's not able to do, we'll see once we start looking at some of the configuration pipeline. That is the next topic which we're going to cover. We'll come to that. So anybody got success with adding zip codes? I'll go ahead and show you how to add that. So for adding any new thing, right, if I had to add to make it understand that I can also provide zip code. So I'm going to do this. Intent is the keyword. You can't misspell or change that. And I'm going to simply call it as let's call it zip. I'm going to give some example. That one of the example is 28027 94403 63122. That's it. I'm not going to give many example. And if I now go and train that, actually let's give this, make these also an entity, and we're going to provide that these are all zip code. Okay. And if I retrain this, oh, sorry. RASA train NLP. And I can see that the entity is getting trained. Zip code is showing up, and I also found an intent called zip. So hopefully I should be able to add that. And I want to show you what happens if I provide a little bit different format of numbers and combination. Let's see how does it behave. So these epochs which you are seeing here, right? Epochs are nothing, just a fancy word of going over the data multiple times in different combinations. So we'll be covering this in the second one, but just to give a flavor, right? When the models are created, when the models are created in the stories, right? So we only defined couple of paths, that here are the 5 different flows, but in real world it can go you cannot define basically every single path. For example, if customer says hi and bot says how are you, and instead of saying mood greet, you say the weather is good today, so I think I'm okay. You won't find that sort of responses or utterances anywhere. So the way bot, what it does, it creates a combination of multiple flow. It just creates a permutation combination of multiple flow and creates its own path. It might come back as and create a random path called happy path underscore sad path 1, and it'll pick couple of lines from here, couple of lines from here, and create altogether a new path out of that. And then so it is going to continue creating. I think it by default it creates up to 200 different flows. So as many paths you have, multiply that with each story, each flow will be you'll be using it 20 times and it's going to create 10 different flow out of that. So at any given point of time, you'll have 200 flows created by default by the chatbot. Okay, so let's quickly see whether my zip codes are added. So far we haven't done any coding. It is just plain English language. We are doing that. We'll have very small amount of coding when we get to this session too, but I'll provide the code. That is just to show you how. So basically when you're creating a chatbot, right, the chatbot won't know the answer to everything. It has to connect to different pieces. For example, you may have a requirement that when somebody provides a zip code, it should be a valid zip code. Chatbot can't do that. For those, we'll be connecting to third-party services. Google Maps service to validate whether the zip code is valid or not. You don't want to provide for example, couple of times I mistyped some of the words there, right? I misspelled build with UILD, but it was able to understand. But you don't want to have a scenario where somebody is dying, I'm dying of a heart attack, here is my zip code, and they mistyped the zip code, but it still comes back with an address. So for those, you would want to validate a zip code. If somebody provide your phone number, please call my wife that I'm dying of a heart attack, or I have a medical emergency. It should be, you need to have some service to validate whether the phone number is valid or not. So for those kind of stuff, you would want to connect to some third party service. So in the second one, in the second session, we are going to look at some form of code, and which will be a sample code you can replace with your own code if you want.
Dinesh, can I ask a question?
Sure.
You may have covered this, but in that specific instance of an emergency situation,
right?
Would the chat box be able to recognize that and move that person to a live person?
Yes, you can. You can. So when we get to this session 2, and we're going to talk about dialogue management, we're going to review that what happens when you ask a question and chatbot is not able to do that. So imagine right now we are building a text chatbot, right? When I was playing with the voice chatbots with the IBM, I was comparing IBM Watson service, Google service, and Bing. And every person has different dialect. As an Indian, my accent might be thick. As a Southerner, their accent might be even thicker. Even people here, somebody from New York may not be able to understand that. So in those cases, when a chatbot doesn't understand, you can provide a policy that, okay, if I don't understand a question 3 times, you can choose what you want to do next. You can tell your chatbot, go call a person or just hang up on the person. That depends on your flow, and you can configure that. It can transfer your calls, okay? So let's put in the zip code. So it is able to identify it's a zip code. Now let's give example of a wrong zip code. I just put in a dump and it still come back with a zip code. So these sort of scenarios, sometime you may have a requirement to validate something. The chatbot is not going to do that. You have to either write a code or you have to use a pre-built code that your backend team has built to validate a phone number, zip code, and it can tell you that although it's a zip code, but the number you provide is invalid. So I'm going to ask you a follow-up question to re-enter your zip code, right? So with that, we just added a zip code, a new intent, and I defined that. So moving on, so Nanji, coming to your question, which you asked, how much data do I need? So in contextual one, you can start with the 10 to 15 example per intent. So if you would have seen, we played around with some of the sentences which were not defined in the intent, where I asked that show me a doctor's office, or find me a doctor, find me a nurse, or find me a dentist. It was able to find the search facility. You don't have to provide all the different types. But what you need to do is you need to define data which is of high quality. And by high quality, I mean something which will help chatbot to learn the structure of a sentence. Like I kept saying, right? If I'm teaching somebody grammar, and there's a grammar rule which says that a noun should come before a verb or adverb should come before a verb, you need to put those exact sample values in there. You don't have to put all different possible values, meaning substitution is what I'm talking about. For example, if I go back here and then say, show me a health agency, show me a doctor's office, show me a something. They all, to the bot, they all mean the same thing. They all fall under the same bucket that you're trying to find something. The first three sentences are the same. Show me, and then after that it's going to followed by what you're looking for: a hospital, a nursing home, a dentist office, and that is how it's going to do that. So you don't have to provide all the different example. Just one or two example should be good, but you need to make sure that they are in the correct intent. So for example, I'll go back to the old one. What is the cost of a baby monitor? Would be something for, would be put under something called intent product search. What is the cost of hiring a nanny to monitor my baby? Would be a different intent. Probably say, let's call intent hire Craigslist. So that sentence would go in there, and the chatbot is going to create a rule set in the background that these are the words. If they're in such and such placement, this is the intent. So you don't have to provide multiple, but they should be high quality data. Did that answer your question, Nanji?
I think he dropped out of the call, but I'll make sure he watches the recording.
Okay. Sure. And the next one is if you have a high quality vocabulary, prep your bot for SATs. Teach them all the different synonyms of a word. Balance in regular life versus balance in banking domain means two different things. So you can train, like I can create an intent for what is the how much does it weigh on a weighing balance, would be an intent for intent called weigh, and another intent for cash, intent cash, what is your account balance is with related to your bank accounts. So those are the kind of combination that you can provide in your intents, providing different sample, how a word can be used differently in different intents. So, and that is where when we look at something called pipeline, you will see that how it is able to do. So RASA internally uses TensorFlow library to create the word embeddings, and we learn what those are. So next thing we want to understand is, how does my bot understand what the user is asking? How is it able to break a sentence and make out what is the context, what is the entity, and how does it break up? So that is controlled by something called processing pipeline. So processing pipeline is just a small set of code joined together to do a complex task. So the RASA chatbot has these 5 different broad buckets of steps that it does. So it does something called tokenization, something called featureization, entity recognition, intent classification. We understand these words, these 3 buckets, we would understand what they mean, right? So it does something in the beginning, and then that is after that it is able to do entity recognition and intent classification. So we are defining these as series of steps. So let's look at what are the different type of pipelines, right? So if you want to play around and see where your pipelines are defined, you can go in your folder and there is a file called config.xml. And if you open that file, you will see there is a series of steps which have been defined over it. We're going to go over them one by one, and we're going to play around in exercise 4. So hopefully you guys have installed the Spacey library, which I showed earlier. I should have installed by now. So this is an example of a pipeline, something called, I'm doing some form of tokenization, something called featureization, something is syntactic count feature, and so on and so forth. This is a pipeline. When somebody provides a sentence, this is, think of this as a program which runs, then it hands off to the next one, then it hands off to the next one. So it's a series of steps that is happening in a given pipeline. So there are two kind of pipeline. One is called pre-configured pipeline and other is a custom pipeline. So an example of pre-configured pipeline is convert RT tokenizer and so on and so forth, and this is a custom pipeline. So if you go back to your example, you would see that we are using a custom pipeline. By default, it creates a custom pipeline for you. White space tokenizer regex feature, which is what is defined here. So when would you want to use a pre-configured pipeline? When your training data is English, which is one of the most widely used language, there are a lot of pre-trained libraries that have already trained on hundreds and thousands of text. If somebody has got a chance to attend FastAI, in one of the lectures, they are using a library, FastAI library, which is trained on Wikipedia. So it has the library, the model which is available. It has gone through all the text that is present in Wikipedia and understands every different complex combination of sentences you can throw at it. City names, state names, it would have found, if it has found something in the Wikipedia text, it understands that this is a state. And that is why when we were dumping in some of the states, it was not able to recognize, because ours is a custom pipeline, meaning it knows some of the words and it is able to figure out that it may be a city, but on the other, it is not able to figure out whether it's a city, state, or what is the entity type in it. And that is why a custom pipeline is typically used for a language where you don't have a predefined model. You can train your own model. That here is so for example, let's say there is no model in the world for German language. You can train your library and create your own model library just to understand the German languages. In German language, there is no concept of in a sentence you will not be able to tell whether they're talking about a male or a female, and their grammar sentences is also different. French is another example where their grammar is really difficult to understand, right? So if you want to train your data which is not in English and there is no model available, or you want to train your data in a totally different domain, it could be in English, but your domain is about, say, medical industry, or it is about genealogy, where I talk about genomes, KT lexical value and all those stuff, which I don't know what I'm talking about right now, but genome. But imagine you have that sort of requirement, then you would want to create a custom pipeline where it would understand that a word like HDL, LDL means you're talking something about cholesterol. So that's when you will be using a custom pipeline. And so what the pipeline basically does is, the first three steps is it tries to create a word embedding. You'll hear this word in the RASA library and any of the chatbot which you're going to talk about. So word embedding is nothing, it's just an association of similar text in a group. For example, if I say I want to buy an apple, you define that as intent is get fruit. And then you ask a question, I want to get some pears. The tool predicts that it is of type intent get fruit. And the way it does it, it uses a pipeline component called convert RT featureizer. There are many featureizer available to you. Right now in our current one, I think we are using regex featureizer and a lexical syntactic featureizer, right? So that's what we are using. Convert RT featureizer is one which is available to you if you're using a predefined pipeline. Spacey provide a good pipeline for doing all of this stuff. So convert RT featureizer is something which is available for English language. That is why you cannot use this for German or French. So if you try and understand what these tokenizing vectorization is going to do, is all this embedding is simply going to create tokens, which means If I say something like I want to buy an apple, it is going to break it down into the first series of step in the pipeline tokenization. It breaks every single word into a one token, and it's going to say all these words appear together, so their weight is equal to something. So if anybody is from like if you have studied computers in school, you would have learned about binary numbers, right? So 2 can be written as so binary is base of 2, so 2 can be written as 1 0, 5 can be written as 1 0 1. So it does the exact same thing. It creates a vector of these words, that if I see this word, this word, this word, I'm going to give it a weight of 5. If I see I want to buy an pear, the weight of the number is still going to be the same, because they're all similar, because I can see that most of the word are available. I want to buy an apple, so 1 2 3 4 5 words are similar, fifth one is possibly the same. And that is how you see the confidence level changing. When we talk about confidence level here, that is how it does that. What is the confidence level? How did it come at 99? It came at 99 because it was able to figure out that first 4 words are similar. You're asking me to predict on a new utterance altogether, and the first 4 are similar, so I'm 99% sure that this is a pair. And the percentage, it can be calculated via various formulas, so each library can come up with a different percentage value, and we're going to see that in exercise 4. Okay, so in the pre-train embedding, think of it as I know it all. You know, the guy who used to sit in the front bench all the time. Whenever a teacher asks questions, he always raises a hand, I know it. And sometimes they ask, sometimes they don't. So pre-trained embedding is exactly that. It says I know everything about a certain language. You don't have to go outside of that. And one of the library which is available is come from Spacey. Spacey is one of the library where it provide all of these features as individual module that you can use. Now, when you're creating a pipeline, you are not limited to just using one form of tokenization. So when I say tokenization, means break the sentence into different words. And there are multiple libraries to do that. You can join multiple libraries. You can use a tokenization library from Spacey. You can use a tokenization library from, there's one more called, for Chinese language, there's a library called GB. You can use GB, and you can combine all of them together, because sometimes, you know, for example, I speak 3 or 4 languages, and sometimes I mix some of the words. Say Hindi and English will mix. If somebody is German and English is not his first language, while speaking English, he might, you know, throw in some of the German words in there. So because of that sort of thing, you can RASA provide option that you can combine multiple tokenization library together, and in the end, it is going to come up with the same form of token as it would have done with just a language, with just English word or German words. Okay. So you can combine these with any number of libraries together for each of the process. So what are the advantages of pre-embedding, right? So one of the advantages, you're always going to get a better model performance with less training data. So in our case, if I was using a pre-trained library and I would have provided a city, any of the US city, I would have always gotten 99% response in that this is a city, even though you haven't identified. I know it because I trained over Wikipedia, and I know all of these states or cities or countries or rivers out there, and I can tell you exactly what is in there. Your iteration time is going to be faster. So right now, when I train, right, it takes a couple of seconds with just a few intents and sentences out there. It still takes me about 10 to 15 seconds. But imagine if I have a very big model and I have to train, it's going to take a long time to create the model. With the pre-trained embedding, the timing is going to be much less. But the problem with these is you are limited to the library which are already available. If you use a pre-trained library for English and try to use it on French, you may not get accurate results. And if you are doing something domain specific, so you're building a chatbot for a banking domain or a medical domain or say a fashion designing domain, those domain specific word you won't be able to train. When you say balance, it will always talk about weighing balance. It won't understand a domain specific to a bank, that a balance in banking domain means your cash balance, right? So those are some of the advantages and disadvantages of pre-trained embedding. Supervised, it's where you keep providing data to keep improving, and these are specifically useful when you're training in a new language, or you're training in a specific domain like medical domain, where you're using BP for blood pressure, LDL, HDL, cholesterol terms. That is where you would want to use supervised embedding. The only backdrop of this is that you need to provide more data. So like Nanji was explaining, right, I want to build one, I provided 10 to 15, and it is performing reasonably well, but then when I'm looking at the record, 50% of the time it was not able to understand some of the sentence. What should I do? The solution is go ahead and update your model, add those couple of entrances, see if your model performance improves, and then you stop. Then you keep recording. It's an ongoing exercise. Eventually your model will get really advanced, will be able to understand everything over a period of time. So it keeps learning, and with this you are not limited to a particular language or a domain. You can do whatever you want to do, and it can also handle multiple intents. Balance in real life, balance in banking domain. It would be able to understand that, right? So without much ado, if I cut the crap and just tell you which to choose, is if there are already pre-trained embedding available, then you need to check, do you have a need for multiple intents? If no, then you can go ahead to use pre-trained embedding, otherwise go for supervised. If you have any domain specific term, go with the supervised thing. If you have a lot of data, then definitely go with supervised embedding. If not, you can do pre-trained embedding. You can also combine them both. You can also say that use a spacey tokenizer and a white space tokenizer, which is one is trained and one is untrained. You can combine them both as well. So what you do is you first provide that use a pre-trained embedding, and if that word is not found in there, then continue with the white space tokenizer, where it is simply going to break it up. So you can create a hybrid as well. It is very flexible, or you can create one of your own, however you want to do that, right? So with that, we will try and explore the pipeline for exercise 4. 10 minutes, I think we are pretty close. Oh, okay. So what we're going to do in exercise 4 is we are going to see how is the performance of our model when we change these pipeline. So let me open exercise 4. Okay. So what we're going to do first is we checked some of the one, like find mid octet was 99.9, and you would be looking at the config.yaml file, and there you have something called min-gram and max-n-gram, right? So let's do this. Let's change this min and max gram to 1, min 1, max 1. Okay. And now we're going to train that in the background. So right now we are still using the custom one, but what we are going to learn here is what happens in min and max. So what it does is whenever you are looking at a sentence, right? Say my sentence is what is your name. So the way it tries to create bucket is it's going to start with min gram 1, meaning it'll create a bucket of all the word which have just one word in there. What is your name? It is going to create all the single word in one bucket. Then it is going to say what is going to be a bucket of 2 words together, is your name. Then what is your 3, is your name 3, and what is your name 4. So it is going to create a bucket of 1 words, 2 words, 3 words, and 4 words. I'm going to do that. which is going to improve in helping the context of the question. But now we have changed it to 1 and 1. We said min is 1, max is 1. So it will only create a bucket of 1 words, right? So, and when I search with that, RASA shell NLU, you'll start seeing the difference in performance. So we're going to search with just with hi, and let's, before that, do I have the old one? We're going to see that some of the performance is going to improve for single word. If it is a multiple word, right? Show me a doctor. You'd see that the performance has gone down 91.3. Earlier it used to be 99, although we picked up the exact same sentence. So why it is happening? Because show me a doctor, it only has one word. Right now for it is very difficult for it to create a context out of it. If you start asking a follow-up question more complex, it's going to fail, right? If I change this as give me a doctor's address, again you see that you'll never get to 90% or 99%. It is always going to drop, right? So what happens if we move to a pre-trained model? So let's go here, and now I'm going to comment and use this model, comment this whole thing. Let's copy this and switch it over here. Okay, let's retrain the model, and we're going to ask the exact same questions now. So for people who miss that, if you're going to add this pipeline, it is going to complain that you need to add a spaCy library, right? So for that, you need to run these command, pip install upacy and pip install download. So spaCy is the library, and this is the model for your English language. It would install that, and it will be able to figure things out for you. Okay. Did it train? It's still training. So right now it's trying to load spaCy model with name, and this model, the spaCy model for English language, it's a big library. Imagine thousands of pages on Wikipedia. It is compressed into one to understand what you're talking about. And so the first time it's going to take a while, but in a couple of seconds we'll be able to train everything. Okay. So now it is trained, and now we are ready to try our questions again. So our model is now big because it is using spaCy. So it's going to take a little bit longer to load the first time, but the next time on it's going to be really fast. Okay, so let's first do hi, and now you will see that it has gone down to 62. And now if I could find me a doctor, the thing has changed to 55, right? So why is this happening? Because we are using a pre-trained library that is able to find out your context of your questions. This pre-trained library is more about generic thing because it has been trained on Wikipedia. What we are asking is domain specific. We are asking for a domain for a medical facility. So that is why its percentage are going to drop drastically. So that's why our model which we train, it is going to always going to perform well with the custom pipeline, right? And but you'll see that even though it is a generic model, it is still able to figure out with 55% confidence that you're asking for a search provider type facility. Now let's take the example of Washington, Seattle, which we didn't get back correct. And with this, we are going to get 71.8 07. If I just provide Washington, it is able to still come up with the correct one. And then the St. Louis one, when I provided MO, it was not able to get it. It said that intent was greet. Let's see if that got fixed. So now you see it is able to even figure out the word MO is for Missouri, and it is able to do that. In the previous model, it used to show us greet. And when I changed from St. Louis to full word Missouri, only then it was able to understand that it's an informed type intent. But with this model, since it's pre-trained, it has probably seen this word St. Louis, Missouri in some context, and it is able to figure it out correctly over here. Okay, so that's how different models work. You can combine them, you can change them, you can play around with the existing one and see how the model works. Okay. So now quickly going over all of these pipelines. So the first one which we have is white space tokenizer or spacey tokenizer, which is the first one in our pipeline. If I was using this is for untrained, this is for pre-trained. So what spacey NLP, the first one is, this is not a token, this is just for loading your library for NLP. This is the one which is the actual tokenizer. So in the tokenizer, what it does, it breaks your word. I am looking for a hospital, so it breaks into one word buckets for you, right? So this is good for spacey, and white space is good for your English. Even white space is good for any language, but there are other one like the Chinese language is a symbolic language. Of symbol can mean a whole word and sometimes it can mean a whole sentence, because it's a symbolic language, one of the most difficult one. But even for that, we have a library called Jiba, which can break it up for you. Okay. And next, how does, so after it has broken it down, right, now it needs to understand that what each word means. Is there an entity in there? How do I identify it? What is the structure of that? So for doing that, it moves on to the next pipeline, where it is going to extract the entity for you. So it is going to use, so right now for our entity extractor, we have been using diet classifier and entity synonym mapper, and in spacey we are using CRF entity extractor, which is a very good library. And what it is doing is, it is the other thing which is not covered is called spacey featureizer. So featureizer is basically going to be creating tokens out of those words. So for example, if I go here, right, it is going to create a bucket of token for words which are occurring together in multiple sentences. For example, what's the weather like tomorrow in Berlin? What is the weather tomorrow? So weather tomorrow, weather like tomorrow are basically asking the same thing. So featureizer is going to be creating features out of them. That this is a kind of feature where you're asking for a weather, and you're asking not exact date, but in term of tenses, future tense, past tense, and so on and so forth, right? And based on that, it is going to be extracting the entity which we have defined with some level of confidence and match it up. And there are multiple libraries for that, right? So there are libraries for CRF entity extractor, which is good for custom entities, which are which you have defined. There's a spacey one. This is for pre-trained entities. If I provide something like Mount Everest, it would be able to identify that Mount Everest is an entity, even though you haven't defined any label for that, but it will be able to do that. Duckling is another one. So duckling is one which is used by Google, Bing, and all others. So this is a good one which can understand your grammar, and also it can figure out when you say tomorrow, it means today is June 2nd. Tomorrow means June 3rd. When you say day after tomorrow, it will be able to come up with that it is going to be June 4th and not something else. If you're going to use something like spacey or CRF, it may not be able to convert those values for you. Then you have MITI entities synonym mapper for mapping synonyms. So if you're going to create something like a sentence can have multiple intents, you would want to append entities synonym mapper, right? So duckling is one of the example. You can also come up with your own custom entity, right? So for example, if you are working in a fashion industry and you say that I have dress available only in green, red, and blue, these are the only color I understand, you can dump them in a table, in a text file, CSV file, and it will be able to understand that. Or you can also,
Dinesh, do you want to save some for next time?
I think I'm done actually.
Oh.
Just 3 more slides and then we'll be done with it. I don't have any exercises anymore. So if you want, in 5 minutes, I will wrap it up.
I feel like probably people probably want we'll do a little review next time anyway.
Sure. Yeah. Okay. Okay. I can stop them. Yeah. It's just couple of more slides. You guys can. The slide is also available on the GitHub. You guys can just go over the slide. All I'm talking about is what are the words, some of the things I've already talked about, balance versus balance. And you can see how the vector is created. But I'll cover that in the next session as well, the last few of them.
So at the end of the talk, I want to ask everyone to, if possible, turn on your camera and unmute yourself, and give Dinesh a big hearty clap. Let's thank Dinesh for his awesome workshop. So thank you, Dinesh.
Thank you.
Thank you. Really excellent.
Thank you so much.
Thank you.
Yeah, I guess if you have some more questions, feel free to ask.
Yeah.
Now before we end the call.
Yep. And you can download and play around. I know some of you are not able to run. You are focusing on what I'm talking about and just watching it. The exercises are there. Everything is documented in the word. You just have to follow. You can just copy paste and see how things are working, and then you can play around with that. So you have a whole week. Next week we're going to be continuing from exercise 4 onwards, and going to be building on the dialogue management, where you'll be teaching bot to respond back to you. Now that you know how it understands, next one we're going to be talking about that. So don't miss that class. That is going to be a really interesting one, and we'll conclude our chatbot. And as a bonus, if we have time, I'll actually show my solution of doing the primitive way of creating a chatbot, the mistake, what I did, so you guys don't run into those issues, how to solve those. Okay. Okay, that's all I had. Thank you everyone for jumping. I know I went by a couple of minutes over, but hopefully you guys enjoyed the session.
Yeah, it was awesome. Thank you so much. I'm sure you mentioned it, but you work for Wells Fargo. Which group are you in?
So I'm in payment and virtual solution PVSI group.
I gotcha. I'm in Cedar under customer excellence. We're doing a lot of NLP work.
Okay.
So really enjoyed your NLP related stuff. Looking forward to other sessions. So thank you so much for putting in the time to put all of this together for us.
Okay, thank you. All right, guys, see you next week. If you have any question, you can put it in the chat or Slack channel. I think, Anita, I don't know if you got access to the Slack. I believe you joined today, so you can ask Chang and get added on the Slack, and you can post question there as well.
Thank you. I'll do that. I do have some catch up to do, but this was great. Thank you.
Okay. All right. All right, guys. Bye.
Thank you.
Bye. Good night. Thank you.
Bye.